question is question number 19. So now see, this is a very good question actually. So in question number 19 it is given P and Q are two identical charged particles having each of mass 4 into 10 to the power minus 26 kg and charge 4.8 10 to the power minus 19 coulomb. So in this question it is asking each moving with speed, same speed of 2.4 10 to the power 5 meter per second as shown in the figure. So this is the charge particle Q and this is your charge particle P, identical charge particle. Q is moving along positive x direction, P is moving along negative x direction. The two particles are equidistant 0.5 meter from the vertical y axis. That means from the vertical y axis this distance is our 0.5 meter and this distance also 0.5 meter as per the given data. At some instant a magnetic field V is switched on so that the two particles undergo head-on collision. But in this question the direction of magnetic field is not mentioned, but it is written at any instant, at some instant the magnetic field V is switched on. Okay, so question is find the direction of the magnetic field so that the two particles undergo head-on collision. Okay, so before solving the question, first we have to think how to determine the direction. First thing we have read about your Fleming's left hand rule, and all of you remember the easy concept behind the Fleming's left hand rule is that is your CMF concept. CMF means stretch the three fingers, that is your middle finger, forefinger and thumb of left hand in such a way that they are mutually perpendicular to each other. In this case, if middle finger shows the direction of current, forefinger shows the direction of magnetic field, then thumb will represent the direction of force. Yes. So to determine the direction of force, we have to think about Fleming's left hand rule. So the substitute of Fleming's left hand rule is your right hand palm rule. So you see this diagram. Okay. So what do you mean by right hand palm rule? So it is a shortcut method for Fleming's left hand rule. We can term it as right hand palm rule. Okay, so as per this rule, what we have to think? This is thumb. So thumb represents you have to stretch, or you have to stretch your fingers like the diagram. So in this case, if thumb represents your direction of positive charge or direction of current. Second thing, these four fingers means this 1 2 3 4. Okay, these four fingers, they have to represent what? They have to represent the direction of magnetic field. Okay, they have to represent direction of magnetic field. They have to represent direction of magnetic field. So in this situation, the palm, this is your palm. Palm represents direction of force. Okay, so this is a shortcut method of Fleming's left hand rule. So you remember this concept. So as for the given question, at some instant magnetic field V is switched on so that two particles undergo head-on collision. So as per our question, now see this. As per our question, this is your y-axis. This is y-axis and this one is x-axis. Okay, one is your y-axis, another one is x-axis, like this. Okay, and here is our charge particle plus Q. Another particle is at a distance. Here this is the charge particle plus P. Okay, Achha. then this distance is your separation 0.5 meter, because this is your y-axis, and this separation also, separation between your p and charge particle p and y-axis, that is your also 0.5 meter. Okay, so in which direction magnetic field should switch on, so that they both the particle will undergo head-on collision, that is our aim. Okay, so now see, I have taken the photo actually, so that you can understand in a very easy manner. See this, if this is the charge particle Q, another picture also there, see this, okay. Now check this figure. In both this figure, you can understand the total question in a very easy manner. See this. So these four fingers, as per my concept, these four fingers represents magnetic field direction. So when magnetic field is inward, these four fingers pointing inward, magnetic field is inward. Suppose the magnetic field is inward. Okay, so at Q, what is the direction of force? Direction of force experienced by the charge particle will be along this direction, because direction of force can be determined by the direction of palm. So this is our palm. Yes, this black point is your palm, black point. This is the palm. So palm is facing towards this direction. So this is the direction of force, magnetic force experienced by charge particle due to the presence of magnetic field. Okay, so similarly at point P, if you will use right hand palm rule, now see, this is the direction of motion of positive charge. Yes, this is along the direction of thumb. Now it is matching. Yes, and if the magnetic field is in inward direction, so what will happen? Suppose the magnetic field is in inward direction, so that means we have to put these four fingers into the plane of paper, pointing into the plane of paper. As a result of this is the palm, white dot is palm, so palm is facing along this direction, that is the force due to magnetic field. And because of this reason, and in case of Q also, this is the direction of motion of positive charge. So you are projecting Q along x direction, positive x direction, and force due to magnetic field is acting along y direction. Now see, because of these two things, the charge particle Q starts to move along this path. Yes or no? It starts to bend. It starts to follow this path. And at P also, this is the direction of velocity vector, initial velocity vector of P. And because of the force due to magnetic field, it starts to change the direction of path. Okay, so at this point, this is the, at this position, they will suffer head-on collision. Yes or no? So this is the site of collision. Site of collision. Okay, I hope it is clear to all of you. So all of you go through this right hand palm rule properly. Okay, and this is a very shortcut method about your Fleming's left hand rule. Okay, so question is asking, if they will suffer one dimensional head-on collision, so what will be the direction of magnetic field? So now we can think, or we can say, direction of magnetic field, inward direction. So first we answer, direction of magnetic field is in inward direction. Okay, I hope it is clear to all of you. And the next thing is, it is asking the magnitude of the magnetic field applied in the region. Okay, it is very easy. So in order to suffer head-on collision, all of you remember, in order to suffer head-on collision, the particle will complete this circular path. Okay, so for collision they must follow the circular path. Okay, and if it will continue to move like this, then the path will be like this, and in this case the radius of this circular path will be 0.5 meter. This will be the radius. Okay, this will be the radius. So as per our question, we can, for second bit we can write, for second bit we can mention, for collision they must follow the circular path of radius 0.5 meter, and in this case radius formula is r is equals to mv by qb. So now you can calculate the value of b. B is equal to mv by qr. So mass of charged particle is given 4 into 10 to the power minus 26 kg. V value 2.4 10 to the power 5, it is mentioned in given data, and charge is given, just see the data, 4.8 10 to the power minus 19 coulomb. So all the data are in SI unit. So 4.8 into 10 to the power minus 19, and your radius value 0.5, and if you will solve you will get 0.04 Tesla. This is your answer. Okay, so again I am suggesting to all of you, please see this right hand palm rule properly. Okay, after that you can understand this question. Okay, I hope it is clear to all of you. In this question number 19, another question is available for BI candidates, that is here, a proton is moving with speed 2 into 10 to the power 5 meter per second. So in given data it is given, you can mention, given V is equals to 2 into 10 to the power 5 meter per second, and charge particle is proton whose charge is 1.6 10 to the power minus 19 coulomb, enters in a uniform magnetic field B value 1.5 Tesla. At the entry, velocity vector makes an angle 30 degree to the direction of magnetic field. It is very, very important. So all of you remember, if this is the magnetic field direction, if this is your velocity vector V vector, and the angle between them theta is given, then the particle will execute which type of path? Helical path. Okay, so the path is helical in this case, and this distance between this two turn, okay, two consecutive turn, that is called pitch. Okay, yes. So question is, calculate the pitch of helical path described by the charge, and the pitch value, first bit, pitch value P is equals to, you remember, 2 pi mv cos theta divided by qb. Now you can use the respective data, 2 into 3.14 into mass value, mass of proton, charge particle is proton, so 1.6 into 10 to the power minus 27 kg. Its V value is given 2 into 10 to the power 5, and cos theta, that is your cos 30 degree, theta is given 30 degree. Okay, so cos 30 divided by qb, q is the charge particle proton, so 1.6 10 to the power minus 19 coulomb, and B value is 1.5 Tesla. Okay, 1.5. So if you will solve, you will get 7.7 into 10 to the power minus 3 meter. So this is the value of pitch. And in second bit it is asking kinetic energy after completing half of the circle. Okay, so in this case you remember, in helical structure, half of the circle kinetic energy. So after completing half of the circle, your speed is constant in this case, magnitude remains constant, okay, but direction changes continuously. So if you will think about the velocity, this is your theoretical part, velocity. About velocity, you remember, direction changes continuously, so velocity is variable. direction changes continuously, but your magnitude remains constant, and the magnitude part is called your speed. So magnitude remains constant, okay, which implies speed is equals to constant. Okay, so the kinetic energy after completing half circle, so half mv square, so that means half into mass of proton is 1.6 10 to the power minus 27 kg, and v square, v value is given 2 into 10 to the power 5, so 2 into 10 to the power 5 whole square. So this is equals to 3.4 into 10 to the power minus 17 joule. This is that answer. Okay, I hope it is clear to all of you. This is very very important question, and in first bit this diagrammatic part is very important. So now with proper attention try to solve this question. Thank you. Have a nice day.